Hello friends, today we will read the chapter 7 of our NCERT chemistry, the P block elements. So here is a quote written: diversity in the chemistry is the hallmark of P block elements manifested in their ability to react with the element of S, D and F blocks as well as with their own. So now the introduction of the chapter starts. In class 11 you have learned that P block elements are placed in groups 13 to 18 of the periodic table. Their valence electronic configuration is NH2 NP 1 to 6. Except helium, which has 1s2 configuration. The properties of P block elements, like that of others, are greatly influenced by atomic sizes, ionization enthalpy, electron gain enthalpy and electronegativity. The absence of d orbitals in the second period and the presence of d and or f orbitals in the heavier elements starting from the third period onwards have significant effect on the properties of elements. In addition, the presence of all the three types of metals, metalloids and non-metals, bring diversification in chemistry of these elements. Having learned the chemistry of elements of groups 13 and 14 of the P block of periodic table in class 11, you will learn the chemistry of the elements of subsequent groups in this unit. Group 15, and now the topic is group 15 elements. Group 15 includes nitrogen, phosphorus, arsenic, antimony and bismuth. As we go down the group, there is a shift from non-metallic to metallic character through the metalloidic character. Nitrogen and phosphorus are non-metals, arsenic and antimony metalloids. Nitrogen and phosphorus are non-metals, arsenic and antimony metalloids, and bismuth is a typical metal. Now occurrence. Molecular nitrogen comprises 78% by the volume of atmosphere in the Earth's crust. It occurs as sodium nitrate, NaNO3, called Chile saltpeter, and potassium nitrate, called Indian saltpeter. It is found in the form of proteins in plants and animals. Phosphorus occurs in minerals of the apatite family, Ca9PO46 CaX2. X can be fluorine, chlorine or an OH group. For example, fluorapatite Ca9PO46.CaF2, which are main components of phosphate rocks. Phosphorus is an essential constituent of animal and plant matter. It is present in bones as well as in living cells. Phosphoproteins are present in milk and eggs. Arsenic, antimony and bismuth are found mainly as sulfide minerals. The important atomic and physical properties of group elements along with their electronic configuration are given in table 7.1. So here is the table 7.1. You can refer it, pause the video and you can read it. I am moving further. Trends of some atomic, physical and chemical properties of groups are discussed below. Electronic configuration. The valence shell electronic configuration of these elements is NH2NP3. The s orbital in these elements is completely filled and p orbitals are half filled, making their electronic configuration extra stable. Now atomic and ionic radii. Covalent and ionic in particular state. Covalent and ionic in a particular state, radii increases in size down the group. There is a considerable increase in covalent radius from N to P. However, from arsenic to bismuth, only a small increase in covalent radius is observed. This is due to presence of completely filled d and or f orbitals in heavier members. Now ionization enthalpy. Ionization enthalpy decreases down the group due to gradual increase in atomic size because of extra stable half-filled p orbitals, electronic configuration and smaller size. The ionization enthalpy of the I am reading it again. Ionization enthalpy decreases down the group due to gradual increase in atomic size. Because of extra stable half-filled p orbitals, electronic configuration and smaller size, the ionization enthalpy of group 15 elements is much greater than that of group 14 elements in the corresponding periods. The order of successive ionization enthalpy as expected is, you can read it what is written, delta I H1 is smaller than delta I H2 is smaller than delta I H3. So we have to refer table 7.1 for this. So this is 7.1. So you can see ionization enthalpy where it is written. Yes, it is, we can see it is decreasing down the group. So for nitrogen it is 1402, for phosphorus 1012, for arsenic 947, for antimony 834, and for bismuth it is 703. So this is written here that first ionization enthalpy, second ionization and third ionization enthalpy. So you can see first ionization enthalpy is smaller than second ionization enthalpy, which is smaller than third ionization enthalpy. So you can see 1402 for nitrogen, first is 1402, second is 2856, and third is 4577. Similarly for all, this implies that first ionization enthalpy is smallest and second is larger than first and third is larger than second. So that is the thing which is written here. So note that we are reading this for group 15 elements, like the chapter is p block element in p, and in p block all these properties are of group 15 elements. Now electronegativity. The electronegativity value in general decreases down the group with increasing atomic size. However, amongst the heavier elements the difference is not that much pronounced. Physical properties. All the elements of this group are polyatomic. Dinitrogen is a diatomic gas, while all others are solids. Metallic character increases down the group. Nitrogen and phosphorus are nonmetals. Arsenic and antimony metalloids, and bismuth is a metal. This is due to decrease in ionization enthalpy and increase in atomic size. The boiling point in general increases from top to bottom in the group, but melting point increases up to arsenic and then decreases up to bismuth. Except nitrogen, all the elements show allotropy. So these are very confusing if it is read from here. If we will refer to table, it will be easy. Like we were reading about physical properties. So if we will move here and see, like density, boiling point, melting point, ionic radius, all these are written here. You can refer it. I am moving further. Chemical properties, oxidation states and trends in chemical reactivity. The common oxidation states of these elements are -3, +3 and +5. The tendency to exhibit -3 oxidation state decreases down the group due to increase in size and metallic character. In fact, last member of the group, bismuth, hardly forms any compound in -3 oxidation state. The stability of +5 oxidation state decreases down the group. The only well characterized Bi5 compound is BiF5. The stability of +5 oxidation state decreases and +3 state increases. This happens due to inert pair effect down the group. Nitrogen exhibits +1, +2 and +4 oxidation states also when it reacts with oxygen, phosphorus, and also show +1 and +4 oxidation states in some oxo acids. In case of nitrogen, all oxidation states from +1 to +4 tend to disproportionate in acid solution. For example, 3HNO2 forms HNO3 plus H2O plus NO. This means that oxidation and reduction takes place of the same compound, like HNO2 is undergoing oxidation as well as reduction. Similarly, in case of phosphorus, nearly all intermediate oxidation states disproportionate from +5 and -3, both in alkali and acids. However, +3 oxidation state in case of arsenic, antimony and bismuth become increasingly stable with respect to disproportionation. Nitrogen is restricted to a maximum covalency of 4 since only 4, 1s and 3p orbitals are available for bonding. The heavier elements have vacant d orbitals in the outermost shell, which can be used for bonding and hence expand their covalence, as in pF6-. Anomalous properties of nitrogen. Now you might have guessed that whenever this anomalous word comes, it means there is some exception and all. So let's start. Nitrogen differs from the rest of the members of this group due to its smaller size, high electronegativity, high ionization enthalpy and non-availability of d orbitals. Nitrogen has unique ability to form p-pi multiple bond with itself and with other elements having a small size and high electronegativity, example with carbon and oxygen. Heavier elements of this group do not form p-pi bonds as their atomic orbitals are so large and diffuse that they cannot have effective overlapping. Thus, nitrogen exists as diatomic molecule with the triple bond 1s and 2p between the two atoms. Consequently, its bond enthalpy 941.4 kJ per mole is very high. On the contrary, phosphorus, arsenic and antimony form single bonds spp, arsenic, antimony, while bismuth forms metallic bond in elemental state. However, the single nitrogen-nitrogen bond is weaker than that of single phosphorus-phosphorus bond because of high interelectronic repulsion of the non-bonding electron owing to the small bond length. As a result, catenation tendency is weaker in nitrogen. Another factor which affects the chemistry of nitrogen is the absence of d orbital in its valence shell. Besides restricting its covalency to 4, nitrogen cannot form d pi p pi bond as the heavier elements can. Example, R3p is equal R3p double bond O or R3p double bond CH2, where R is some alkyl group like R3 phosphorus and R is alkyl group and it is double bonded with oxygen, or R3p, R is alkyl group and with phosphorus and double bonded with CH2. Phosphorus and arsenic can form d pi bond also with transition metal when their compound like P CH C2H P with 3C2H5 and arsenic with 3C6H5 acts as ligands. Now, reactivity towards hydrogen. All the elements of group 15 forms hydride of the type EH3. So we should remember this is a general format EH3, where E double bond N, P, AS, SB or bismuth. Like E can be nitrogen, phosphorus, arsenic, antimony and bismuth, and it forms EH3 type bond like NH3, PH3, ASH3, SBH3 and BIH3. Some of the properties of these hydrides are shown in table 7.2. The hydrides show regular gradation of their properties. The stability of hydrides decreases from NH3 to BiH3, which can be observed from their bond dissociation enthalpy. Consequently, the reducing character of hydrides increases. Ammonia is only a mild reducing agent, while BiH3 is the strongest reducing agent among all the hydrides. Basicity also decreases in order. NH3 is more basic than PH3, which is more basic than ASH3, which is more basic than SPH3, and SBH3 is like equivalent to BH3. It is in some case the basicity of SBH3 is equal and in some case it is larger, like we can observe it from the table here. NH3, PH3, ASH3, SBH3, BiH3, the melting point, boiling point and EH distance. EH distance means like NH3 distance of N from H, in PH3 distance from P, distance of P from H, and consequently in all, and distance is given in picometer, and bond angle and all like HEH bond angle like NH3. So HNH will form a triangle and the angle HEH is the bond angle which is given here, and delta formation H means delta H of formation and delta H of dissociation, all are given. Dissociation is given for EH bond, like for NH3 it is for NH bond, and you can refer this, pause the video, and I am moving further. Second, reactivity towards oxygen. All these elements form two types of oxide, E2O3 and E2O5. The oxide in the higher oxidation state of these elements is more acidic than that of lower oxidation state. The acidic character decreases down the group. The oxides of the type E2O3 of nitrogen and phosphorus are purely acidic, and that of arsenic and antimony amphoteric, and those of bismuth is predominantly basic. Third is reactivity towards halogens. These elements react to form two series of halides, EX3 and EX5. Nitrogen does not form pentahalide due to non-availability of d orbitals in its valence shell. Pentahalides are more covalent than trihalides. All the trihalides of these elements except those of nitrogen are stable. In case of nitrogen, only NF3 is known to be stable. Trihalides except BiF3 are predominantly covalent in nature. Now, fourth is reactivity towards metals. All these elements react with metals to form their binary compounds exhibiting -3 oxidation states, such as Ca3N2, which is calcium nitride, Ca3P2, which is calcium phosphide, Na3AS2, which is sodium arsenide, and Zn3Sb2, which is zinc antimonide, and Mg3Bi2, which is magnesium bismuthide. Now, there is a question given, and the in-text question is given. You can refer this, and our next topic is dinitrogen. We will continue dinitrogen from the next video. Now I am ending this video. Please subscribe to my channel and press the bell icon to be notified when the next video is out. So thank you, have a good day, and best of luck.